สวัสดีครับ In this clip, we will discuss the solution of the test number 1. Okay. Let's start from the problem. In the test number 1, the problem is the consumption of natural gas by a company satisfies the empirical equation V equal to 1.5 OT plus 0.008 OOT square, where V is the volume of gas in millions of cubic feet and T is the time in months. Express this equation in unit of cubic feet and seconds. Assume a month is 30 days. Okay. So in this problem, it is about the unit conversion. So before we go to the solution, let us discuss a little bit about the unit and its importance in physics. Okay. In this course, we study general physics, which is the basic physics. You may know from your high school that physics is a branch of science. You may say that science has 3 branches. That is the physics, chemistry, and biology. Okay. Sorry. Okay. These branches of science has specific. Each of them has specific. Detail of each branch, and specifically for the physics, we know that the physics is quantitative science. When we say that physics is a quantitative science, mean that when we express the knowledge of physics, we have to express the knowledge using the number. Okay. This is very different from biology. You may say that biology is a qualitative science. Even though for the modern biology, they try to make the subject quantitative, but in general, you may say that biology is a qualitative science. It means that when you express the knowledge in biology, you may express it like in the descriptive way. Sometimes it's not possible to talk about the knowledge of the biology quantitatively, because biology is so complicated. It is very, very hard, at least for today. Many things we cannot do the calculation in the biology. But in physics, we have to express the knowledge in physics in number. So it means that it is a quantitative science. If you express the knowledge in physics by uh, descriptively or describe it without specifying the number, that is not complete knowledge in physics. Okay, chemistry is in between. Okay, chemistry is in between physics. Something in chemistry you may do the calculation, but in something you may not able to do the calculation. For example, if you study the biochemistry, okay, it's very close to the biology. But if you study like a physical chemistry, it's very close to physics. So chemistry is in between. Okay. And when we say the physics is quantitative science, it means that we have to express the knowledge of physics in number. And to express the knowledge of physics in number, it means that you have to express the quantity in physics in number. And if you want to express quantity in number, in general, you need the unit. It means that if you want to express something in number, in general, it means that you compare that number that you assign to that thing with a standard. Okay, and that standard is the unit of that quantity. For example, if you say that you are 180 centimeter tall, what you mean by this number 100 centimeter? It means that if you compare yourself with the standard centimeter, this may be the standard centimeter, your height is 180 times compared to the standard centimeter. Or if you say that you are 6 feet height, it means that if you compare to the standard foot, you are 6 times, your height is 6 times longer than a standard foot. So when you express, for example, in this example, that your height, it means that you need a unit. Okay. Now, in this example, you can see that for the same for one quantity, you may express that quantity using different units. Okay. For this example, you can express your height as a centimeter, which means that you compare with the standard centimeter. Or you may say that your height is 1.80 meter, which means that you compare your height with the standard meter, and it is 1.80 times the standard meter. Or you can express your height with the in the unit of feet, which means that you compare your height with the standard feet, standard foot. Okay. So one quantity can be expressed with different units. Many times when we want to communicate with people, when people communicate, when maybe two people talking to one quantity. For example, if you discuss, if two people discuss your height, and these two people may use or familiar with the different unit. To make these two people understand what each other talking, we need the way to convert the unit that these two people use. Okay, and that is the problem of the unit conversion. Okay, so you will see this kind of problem. You will usually you will find this kind of problem usually happen when you solve the physics problem. Okay. So when we see the point of this problem, we can go to the detail of the test. In this test, we want to convert the unit of the rate of gas, natural gas consumption from the million cubic feet per month. Okay, see that this equation expresses the natural gas consumption in the unit of million cubic feet per month, but we want to convert this quantity to the unit of cubic feet per second. Okay, how can we do that? We have two, we may say that two kind of conversion. The first kind is that you can see that we have the unit of the volume is the first for this equation is a million of cubic feet, and we want to convert it into cubic feet. Okay. In this type of conversion, it's quite simple because in first we have the unit of million cubic feet, and we want to convert it into the cubic feet. That is very simple because we just put the million to feet, and we know that million is, if we use the scientific notation, is 10 to the 6. Okay, so when we say that the volume is million of cubic feet, it means that it is the 10 to the 6 of cubic feet. Okay, so the first conversion is to convert from million cubic feet to cubic feet. It is simple. What is a little bit more complicated is when you want to convert the unit in month to the second. Okay, now you have to know that the relation between month and second. Of course, this is simple also, right? Because we know that here we have 1 month is equal to 30 days, and a day is equal to 24 hours, and an hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. Okay, from this, if we want to convert the time of 1 month into a second, we can use this relation. Okay, so we have that 1 month is equal to 30 days times 24 hours times 60 minutes times 60 seconds. This is the amount of the second in 1 month, which is you may use your calculator. Okay, so we have 30 days times 24 hours times 60 minutes times 60 seconds, and it is 2,592,000 seconds. It is 2,592,000 seconds. Okay. This is the amount of seconds in 1 month, and you can say that 1 second is equal to 1 over 259,200 months. Okay, so from this we can use this to convert the unit. We have that V is equal to what? 1.5 t plus 0.008 t squared. 1.5 t plus 0.008 t squared. I ignore the last 2 digits to make it short. Okay, 1.5 and 0.008. Okay, in the unit of million, right? Million of cubic feet. Per month. Okay, and we want to convert this into the cubic feet per second. But we may first convert this into the cubic feet per month first. So we have that this is a 1.5 t plus 0.008 t squared times 10 to the 6th of cubic feet per month. Okay. The next step, we want to convert this expression into the cubic feet per second. And in this step, we have to be careful. What we have to do is that first we have this expression 1.5 t times plus 0.008 t squared times 10 to the 6th cubic feet per month. It means that if we enter t in the unit of months to this expression, we will get the value of the rate of flow or rate of consumption of the natural gas in the unit of cubic feet per month. But what we want to do here is that we want to enter the time in the unit of second and to get the rate of consumption in the cubic feet per second. So we have to change the value of this coefficient to match the new unit. Okay. Let's see. The first coefficient here, the coefficient here must have the unit also. If we have the unit of t as a month, this coefficient is the 1.5 million cubic feet per month square, right? If we enter the t here as the unit of month, okay, we must have that this number 1.5 is the has a unit of million cubic feet per month square. Let me check. Oh, sorry. Here, if we look at this V, okay, so let's change this. V is not the rate of consumption. V is the amount of consumption, right? The consumption of natural gas by company certified empirical equation V equal to 1.5 T plus 0.008 T squared, where V is the volume of gas in million cubic feet and T is the time in months. Okay, so it means that here V is the volume of consumption. If we input T in months, we get the value of V here as a million cubic feet. So let's correct this. So we must not have this. It means that if we enter the time here in month, we will get the value of V in the unit of million cubic feet. So delete this. Okay. And this is month. Okay. So that is the unit of the number 1.5 here. And also, we must have the unit of this 0.008 as a million cubic feet per month square, right? Because this we have this t square here, and when we put the unit of 0.008 like this, the unit of t square cancel with this month square. Okay. Now, if we change the unit of t to second, it means that we have to change the value and the unit of these two numbers, 1.5 and 0.008, also to get the appropriate unit of V as a cubic feet. Okay. So we have for the first number 1.5 million cubic feet per month is equal to 1.5 times 10 to the 6 cubic feet per 2.592 times 10 to the 6 second. Right? Because we know that 1 month is equal to 2.592 or 2.592 times 10 to the 6 second. Okay, so we have this and this 10 to the 6 cancel, and we have, you may use your calculator. This is 1.5 over 2.592, which is equal to 0.579 cubic feet per second. Okay, so we have the first coefficient. The second coefficient is 0.008 times 10 to the 6 cubic feet per 1 square, right? And we know that this equal to 0.008 times 10 to the 6 cubic feet to 2.592 times 10 to the 6 square second square. It means that you convert this 1 square into second square. Okay. Again, you may use your calculator. This equal to 0.008 over 2.592 square times 10 to the minus 6. Because this is a 10 to the 6 square, which is 10 to the 12, and you divide 10 to the 6 by 10 to the 12, you have 10 to the minus 6. Okay, which equal to 0.008 over 2.592 square equal to 0.00119 times 10 to the minus 6 cubic feet per second square. Okay, you may change this number to 0.119 or let's see the choice. Okay, this can be 1.119 times 10 to the minus 9, right? Because we move this number t position. Okay. And in the unit of cubic feet per second square, or a square like this. So the final solution is, when we use the time in second, and the volume in cubic feet, we have V is equal to 0.579 or okay, let's see the choice. Okay, 0.579 T plus 1.119 times 10 to the minus 9. 1.119 times 10 to the minus 9 cubic feet, okay, T square. If you use the time in the unit of second, you will have the amount of gas consumption equal to this expression. Okay, and the answer is number 4, right? 0.579 T plus 1.19 10 to the minus 9 T square. Okay. The answer is number 4.